Hello and welcome to the Road to Autonomy. The Road to Autonomy is brought to you in part by Stantec Generation AV. Stantec Generation AV combines some of the most experienced AV experts in the industry with the resources of a global engineering firm. Stantec Generation AV provides education, consulting, assessment, and guidance to any industry interested in autonomous vehicles. Learn more at stantec.com. Hello and welcome to the Road to Autonomy. I'm your host, Grayson Brulte. On today's episode, we're absolutely honored to welcome back Alan Ohnsman, Senior Editor of Forbes. Alan, welcome back to the podcast.
Hey, Grayson. Happy to be back with you again.
Super excited to have you here because you do an incredible job covering the changing transportation industry. You're ahead on so many trends. You wrote a really great story, I believe it was last week, about parallel systems or autonomous electric trains. So I really can't wait to dive into the electrification of transportation today with you.
Sounds good. Let's do it.
Alan, with that being said, everybody's moving towards electrification, multiple industries, form factors from cars to vans to trains. They're all electrifying. Who stands to win?
Well, I think there are going to be so many winners. It is just an epochal shift we're experiencing right now where an entire new industry is suddenly building up, and it's at every level. Most of the attention has gone to, say, Tesla and the passenger car market. But what's happening on the heavy-duty industrial vehicle side, I think is probably more exciting because that can actually move a lot faster. It's hard to get consumers to change buying habits. You get used to fueling a car a certain way, the culture and habits of owning a personal vehicle. So, some of us are slow to change our habits. Fleets can move a lot faster. And if there's a compelling case that says my fueling cost, my maintenance cost, my cost of ownership amortized over several years is going to be lower, fleets will immediately flip. And that's where the action gets really interesting. So every form of commercial vehicle right now is getting looked at to be electrified, whether it's battery or hydrogen. You just mentioned one that I think is really compelling, freight rail, which has been sort of overlooked, could be sort of a sleeping giant in this space. And there's a lot of interesting stuff happening there.
Freight rail's interesting, even outside electrification, because it's a very low carbon impact way to move large amounts of freight. That will be really interesting.
Yeah, one of the amazing statistics, I was talking to Union Pacific last week, and it's sort of mind-blowing to think about already the fuel efficiency of freight rail, because you see a big train lumbering down the tracks and it's pulling 150 to 200 cars. And the first thing that comes to your mind is not fuel efficiency or energy efficiency, but a freight train gets 454 miles per gallon of diesel fuel, which is kind of astronomical. And that's as it exists today. The problem, of course, is it's diesel, which there's no getting around the fact that diesel is a dirty fuel. It's got to be heavily filtered. It's got to be controlled. That's a real problem. But there's also enormous potential to clean up rail and take something that's already exponentially more fuel efficient than any car on the road that's not pure electric and make it even more efficient. So there are a lot of things that are happening in that space. We recently had an announcement when Joe Biden was in Pittsburgh talking to steelworkers about a deal that Union Pacific is going to buy 20 battery electric freight train sets from Progress Rail and Wabtec, which are two of the biggest makers of locomotives in the United States, big established players in this market, and they're both electrifying. Wabtec in particular is pretty aggressive, and they see electrification of freight rail as an enormous opportunity. And what's going to probably happen, it'll come in phases. Union Pacific is going to buy those trains and use them in yard operations, so not for mainline long hauling. It'll be like pushing cars around a big rail yard, which is not a bad thing to do because if you think about it, a freight train is dirtiest when it's moving slowly and pulling things in an initial phase. It's just like with cars. When you're rolling at highway speed, whatever your powertrain is, you're the cleanest in terms of tailpipe emissions. When you're in stop-start, that's when you get these emissions clouds, exhaust blasts out, dirty black smoke when you're accelerating. So in those yard operations, if you suddenly, can do that with electric train sets, you've taken a lot of pollution. You've gotten rid of a lot of the real bad stuff away, and the surrounding community will be appreciative. So that's one phase. But I think there's a lot of opportunity and excitement about electrifying in other ways. So Wabtec, for example, would say what we're going to do is you might pair one or two diesel freight engines, locomotives, with one or two battery systems. And you might be able to flex that so that at different times you might run on diesel when it's really efficient, like if you're at speed rolling down the tracks, shift to the battery system in places where you're near communities or where your exhaust pollution is likely to be the worst or most harmful. So then you're both getting an efficiency gain, but you're getting a huge reduction in exhaust emissions. And then over time, you would swap out, and whether you go all battery electric or eventually hydrogen, to swap out your diesel system so that you have a perfectly electrified, efficient, non-polluting freight rail train rolling down the tracks, which is really pretty exciting. I mean, it's just an interesting use of the technology.
It's a very interesting use of the technology. I like the approach you described of the hybrid train. It reminds me of Toyota's strategy when it comes to hybrid. But more importantly, I love running the electrification in yards. And if you look at you're going to run electrification yards, you're going to have to pull in the energy in order to electrify the trains. That opens up a whole nother opportunity. We saw an announcement 2 weeks ago from Daimler and BlackRock are teaming up to put heavy-duty charging infrastructure around the country. Imagine putting that at a rail depot and then it can go into an electric truck. That's a really interesting combination to take carbon out of the supply chain.
Yes, that's right. In the case of a freight train, basically a freight train is a power plant on wheels. I mean, they're just rolling power plants. And if you're electrifying something like a train, for example, you have some flexibility that you don't have with a truck or a car in terms of packaging. If you think about an electric truck, like Tesla wants to do an electric semi, okay? Elon Musk has said it'll have something like 500 miles of range, okay? Now, legally, by law, a Class 8 semi-truck with the cab and the trailer cannot exceed 80,000 pounds. If you suddenly have an electric truck where up to half of the weight is in battery, your hauling efficiency is not that great. So you can't carry as much. And then to support that, you would need, an extensive network of much more powerful charging infrastructure to recharge something like a truck. A freight train can get away with probably considerably less battery, and it might be able to use different types of batteries that could be more inexpensive because it doesn't necessarily have to optimize for weight to the extent that a truck or a car would. So there's an advantage there. Charging is going to be a huge issue. So if you own a big freight rail yard, you can probably set up your own power station. That's going to be a little more cumbersome for some of the trucking companies. They will have to rely on a network, an extensive network of heavy-duty charging stations. And frankly, those just don't really exist yet. So as you say, there's an opportunity right now to jump into that space and find some creative solutions, because even Tesla doesn't yet have charging stations that could support a heavy-duty truck. They have a lot of stations for passenger vehicles, but not for trucks yet.
I'll give you an example of how it could work. We had the announcement recently of the Union Pacific Too Simple, where Too Simple is going to haul freight for Union Pacific in the rail depot. You put a heavy-duty electrical charging infrastructure at the rail depot, and then you put it at the other depot site. And that's really interesting. Then you could run it all electric because you have the infrastructure there. Does rail become the complement to trucking eventually as we go to electrification? Because rail has the infrastructure, they have the capital, and to be very frank, they have the engineering know-how, how to build really big, complex engineering projects.
It absolutely does. And here's the other thing that hasn't gotten that much attention. And I've only just begun to sort of begin to come to terms with this through conversations with folks in the freight business. Aside from electrification, something else very fascinating has happened with the rail networks in the United States, which is the universal adoption of positive train control. Positive train control is monitoring sensors and electronics that can help trains brake and avoid accidents and send messages around the network when there are delays, accidents, damaged track, all sorts of things. So we're getting a more intelligent freight rail network that we didn't have previously. That creates the opportunity for much greater optimization, to be able to move more through the network now that you have better awareness of where everything is, how fast it's moving, and what its status is, which we did not have previously. I first learned about positive many years ago, but it was from a different aspect, which was for commuter rail systems that needed to have it for safety, because we had some terrible train wrecks over the years. There was a particularly bad one about 10 or 15 years ago here in Los Angeles with Metrolink, where about a dozen people were killed. And that train was not using positive train control. It did not have the ability to get information about what was on the tracks to stop the train in time. But several companies that are developing both electric technologies and new types of technologies applicable to freight rail keep pointing to the fact that this revolution brought about by positive train control means that they have a more intelligent rail network, so they can schedule stuff more efficiently, they can move stuff more efficiently. There are hundreds of thousands of miles, or tens of thousands of miles rather, of freight track across the United States that's already there. And the owners of those tracks, Union Pacific, BNSF, CSX, they want to just optimize the heck out of what they've already built. And positive allows them to do that. So you both have the opportunity to move way more freight more efficiently on rail than ever before. And then, if you can electrify it, so much the better. If you can then tie your railheads and depots into autonomous trucking networks, you got something really interesting going on. So there's so much potential to increase the efficiency while also cutting carbon emissions from rail and freight movement across the United States over the next 5 to 10 years. It's really remarkable.
And not only is it good for the environment, it'll lower the cost of goods for consumers because it'll be cheaper to ship.
Hopefully. We'll see. But yes, if shipping costs come down, that should be a win for everyone. And obviously, less exhaust emissions, less carbon emissions, that's also a great thing for everybody.
Is positive train control mandated today? Is it a requirement that the trains must have it?
Yeah, the Federal Rail Administration started pushing this many years ago, because it's not necessarily new technology, but only within the last year or two has its adoption become almost universal. I think there was something that the Department of Transportation issued sort of declaring like, we've finally done it. It is a big deal because it should going forward mean much greater safety, but also much greater efficiency. And use of the network gets much more interesting as time goes on.
As freight rail, it's going to take a lot of energy to run an electric locomotive, especially when they start to scale. This raises the question that I think a lot about. Is there enough capacity to support the projected demand? Let's say you're going to run 1,000 locomotives all in electric in a region. Can that grid sustain it?
Today, at this moment, I don't believe so. Recently, I have a piece in the latest issue of Forbes magazine, a profile of Tom Linebarger, the CEO and chairman of Cummins. Cummins is moving very aggressively towards electrification, both battery and hydrogen. But on the infrastructure side, he will flat out say, no, the infrastructure cannot support this. And he doesn't think the federal government has yet done enough to really, shine a light on this and focus attention on the fact that for industrial purposes, the infrastructure is not anywhere near adequate. So we are going to need, a lot more generation capacity, but then it's also distribution of where you access that energy.
And then on the backside of that, there's not enough discussion around cybersecurity and the hardening of the grid for cyber attacks. That's another issue that we're going to have to tackle as more and more transportation becomes electrified.
I think that's right. That's a never-ending topic. I'm not much of an expert on that, but it is something that everyone is aware of because it's a real risk, right? The more we become reliant on a grid, ever more sophisticated digital grid, the risks for all sorts of cyber threats just continue to grow. And so yeah, you're absolutely correct.
Being reliant is a huge issue. We're shifting to an all-electric future. Lithium is in short demand. In an interview in the Nikkei Asia on January 11, 2022, a lithium trader said, based on automakers' electric car targets, we doubt there is a sufficient supply of raw material. If the locomotives are going to go electric, trucks are going to go electric, passenger cars are going to go electric, how is this possible due to not having enough lithium currently?
Well, I think, number one, the rollout is going to be, it's not going to be overnight. And so it will build up. Absolutely, based on current technologies, there is probably not enough supply out there. There just isn't. This is why, you've got J.B. Straubel with Redwood Materials and other companies that are starting battery recycling and recovery programs. That becomes more important. But this is where the issue of can batteries do everything affordably and reliably, is that the only option? And many companies would say no. there is another option, and that's why hydrogen is getting looked at, or one of the other justifications for something like hydrogen, primarily for heavy-duty vehicles. Toyota's going to probably keep slogging it out with the Mirai and hydrogen vehicles in the consumer market, but the real action is not going to be there. It really is on the heavy-duty side, and that would be one way to sort of lower the overall reliance on battery. Because with hydrogen, if they can finally crack it, it becomes such an interesting replacement for natural gas, for diesel fuel. You can burn it. You can do hydrogen combustion. A gas turbine generation at a power plant, you can just run hydrogen through there and combust the hydrogen instead of CNG. That's doable. Cummins is developing these sort of flexible powertrains that might be diesel today, but that are designed to also run on diesel and do diesel combustion. There is some low level of particulate pollution from diesel combustion, but nothing compared to gasoline or diesel or anything like that.
It seems there's a trend evolving in this conversation that the heavy-duty side will really drive the market. Is that a fair statement? Because they have the capital, they have the expertise, they have the infrastructure to do this?
Yeah, I think it's both. In the case of Wabtec on the train side, they're working with GM, right? So they're going to source Ultium battery packs for use in trains. But they're also going to use GM's, Hydrotech, their fuel cell deal. They're going to source that from GM as well. So it's a case where the passenger vehicle side, a company developed something that ideally was going to be used mainly for the passenger market, but in fact might have just as much, if not more, impact on the very heavy side of the market. So I think there's a case where it's win-win for both. But I do think that the advancement of the technology can move more rapidly and be quite impactful with the heavy stuff, but then that has spillover benefits back to the consumer market. So the two work in tandem. I think the heavy stuff has the potential to move quite fast, like faster than the rate of adoption in the broader consumer market.
I agree with that. And what you said about GM, perhaps that becomes another big business line for Mary and the team over there. So good for them. And the heavy industrial side, they have balance sheets. They have access to capital. They have access to credit. They can do a lot where a lot of these smaller startups don't have the balance sheets to really commit the capital outside of Alphabet and the incredible funding they're doing of Waymo. A lot of these companies don't have it, but the big industrials do. So I'm a company and I'm sitting there and I'm a big industrial and I'm looking at electrification and I'm turning into a supply chain geek here, reading book after book around the supply chain and minerals. And I start looking into this, and then I see an announcement on January 20th, 2022. Serbia's government revoked a permit that would have allowed Rio Tinto to mine for lithium in the country due to the potential environmental cost of the project. That raises the question to me, what is the environmental impact of lithium mining? Is it something that we should be concerned about, and the negative impact on the environment when we're trying to do good for the environment?
Yes. In a word, yes. Lithium, it's a salt, and extracting it varies. Traditionally, it's come from places like high elevation, like deserty climes in Chile and Argentina and places like that, or out in Australia. Extracting it typically has required lots of water. And simply, that might be the biggest environmental impact for many of these operations, because if you're taking it from a very dry, arid place and you're using precious water to extract this, that's going to be problematic for farmers and for the local environment, the habitats of wildlife, if you're diverting a lot of that water for lithium mining. So that's the real issue there. There are some places where it might not be too bad to do lithium extraction. I think you've probably been hearing a little bit about the Salton Sea, east of Los Angeles, out in the desert here. And the Salton Sea might be a more unique and compelling source of lithium because it's a very briny body of water and it's very hot underneath it. There's a lot of, not seismic activity, but thermal activity under the Salton Sea. And in this case, it may actually be possible to extract the lithium there without quite so much environmental harm that has occurred in certainly places like South America. But that hasn't really scaled up yet. But I know there's a lot of excitement about the Salton Sea being maybe a major domestic source of lithium in the United States, and ideally one that may not be so harmful to the environment. Because there are already problems with the Salton Sea as it exists today, from dust and pollutants that have built up in that particular body of water that are blowing around the desert region. So lithium extraction in that case might actually be somewhat helpful and less harmful than it has been elsewhere.
I'll tell you a fun fact about the Salton Sea. There's a George Patton museum there. I've been there. So that's a fun little fact about the Salton Sea. I went out there. My grandfather's a World War II vet, and he says, we have to go to this museum. So that's how I got introduced to the Salton Sea. You're right about the potential at the Salton Sea. According to the California Energy Commission, it's projected at producing 600,000 metric tons a year of lithium carbonate. A year. That's a lot. LA Times has done good reporting on this, the potential economic impact from jobs that are created there. However, the towns around the Salton Sea don't want the industry to come there. They're afraid of what might happen to their environment. Does this become a political hot potato issue now?
Absolutely, yeah. I mean, that's kind of a funky desert community out there. I'm sure there would be some concern if there's major new industrial activity, how that could be very disruptive. I don't know that it's yet come up as a major political topic. I mean, we've got a governor's race this fall. It hasn't really been talked about, but it certainly has the potential to be a bigger one. But it absolutely could be this enormous, the economics of it are very compelling because lithium's expensive. I mean, if you look at commodity prices, I haven't looked at it in the last couple of weeks, but lithium's been peaking. All of the commodity metals and materials that go into batteries are pretty high these days. So it's a huge source of future revenue. But obviously, this is California, where you can't do any major industrial project without extensive environmental assessment, impact assessment. So that's a story to be continued at this point.
For listeners that are interested in commodity prices, Benchmark Minerals does an incredible job posting updates of commodities. So I recommend checking that if you are interested in commodities prices. Alan, so we're pulling the lithium out of the earth. We discussed that. The thing that's not discussed a lot, at least here in the United States, is the refining of the lithium, because 90% of the refining of lithium globally is done in China. Why is there not more discussions to refine the minerals here? You can make it a national security issue. There's a lot of things you do. Why do you think the refining of the lithium in the United States is not discussed more?
I think general lack of awareness about how the supply chain is currently structured. So you're right. I mean, and I suspect that that's going to change because there is so much investment in new battery fabrication in the United States. Everybody's going to be making more batteries. GM, Ford. Obviously Tesla continues to scale up in that space. The Korean manufacturers, production capacity in the United States, but that's more sort of final assembly. That's not the processing of all the materials. And I think as the supply chain, just like we're seeing with semiconductors, the awareness that it's a risk to be overly reliant on outside sources, international sources, that, supply chains that can be disrupted, the same, awareness, I think, will sink in with these materials. Like, where is it actually being refined and manufactured, whether it's, graphite or lithium or any of these elements. Certainly if it's China, it is unwise to be entirely reliant on China as your supply base going forward.
I say there's the old line, history repeating itself. We learned that with Saudi Arabia and oil. We're going to learn the same thing with China and lithium. And I'm looking forward to the day when you interview an individual or there's a post on Twitter or TechCrunch where there's a startup that said, okay, we're going to follow JB Straubel's Redwood. JB and the team will focus on recycling, but we're going to focus on an environmental friendly way to refine minerals. That would be a really interesting startup.
Yeah, I agree.
Does this open up the opportunity for the circular economy where we create, we recycle, and reuse to help limit the amount of minerals we're taking out of the earth?
Oh, for sure, 100%. And I think that's going to continue to be, you're going to see a lot more emphasis on that going forward. JB talks about it a lot at Redwood, but I think it's going to get a lot more attention with more companies as time goes on.
We're starting to see companies show that attention, and we're seeing carbon-free in the marketing now. That's becoming a big deal. Polestar, they're planning to introduce a completely carbon-free model, currently called the Polestar Zero. Really savvy move from the team at Geely. Is this the future? Will we see more international car brands start marketing and developing carbon-free automobiles?
I think so. The reason, not just because it's the right thing to do if you can do it, but it's becoming more technologically feasible and affordable to do so. Volvo had an event pre-pandemic here in Los Angeles, and their CEO was sort of laying out Volvo's plans, which I think, influence what Polestar is doing, to do exactly the same thing, that they want to get to this like net zero automobile production, and that's at every stage. So already their plants are powered by renewable energy. That's great. But what about your plastics, your steels, all the materials that you're using? And it's moving towards everything has to be designed to be recyclable and reused, which in the old days, what were cars? They were glass and steel and rubber, and they were materials that were kind of easy to extract and melt down or reform or chop up and use it again. Today, we shifted to very advanced vehicles where, especially with the electronics, the recycling of some of those components has been very difficult to pull things apart and to reuse those materials. So now there's much more of a focus on design in ease of recyclability so that you can harvest and use again and again and again every part of the vehicle. That's really interesting. And what that means for the long-term resale value of a car when there isn't just the utility of the vehicle, but the value of the materials and the reuse of those materials. So yeah, we could see some very interesting adjustments as time goes on. If you have a vehicle that is both produced with net zero carbon intensity, but then also can be fully recovered and all the materials can be used again. So it opens up a very exciting industrial era as well, the total recovery of everything.
That creates the opportunity for track, trace, and verify. That's what Circular's doing. They're doing it with Volvo. They're doing it with various other automakers. Well, they're going all the way down to the mine to say, okay, this was mined in an ethical way. There was no child labor, no slave labor, and it was mined from renewable. And then the key to their success is updating the dashboard in real time. So I think that's going to be a big trend that we're going to see as companies push towards a carbon-free vehicle. The consumer's going to want to say, okay, this is fine and dandy. I don't believe your report. I want to see real-time data. I think that's going to be the big change there to build the public trust with the consumer. Overall, what do you think the consumer reaction will be to a carbon-free car? Will they care? Will they think it's cool? Or they'll be like, okay, it's the same car, it's just carbon-free.
Initially, some people will care. A majority probably won't. And I don't know that it may take a while for the implication to sink in. I think like anything, give it time, that in the early phase, it'll be good for marketing. Some people will care, a lot will ignore it. But as time goes on, that's probably going to end up becoming the standard. So within a decade or so, it won't be novel. It will most likely be a requirement. I mean, if you look at policies that are being implemented in the EU, most likely in Japan, probably in the United States, or at least in California, there's going to be ever more focus on that recyclability and on this net zero carbon intensity products. I think that's going to continue to build in importance.
Will build in importance. Then you raise the question from shareholder activism. Will Hertz, Avis, Dollar Rent-A-Car, will they be forced to introduce carbon vehicles as the shareholders put pressure on them to agree? Is that something that you could see happening?
Yeah, I suspect so. But it becomes more common, of course, as it becomes more affordable. So as options become available. I mean, sticking with the automobile that is net zero carbon, I'll be a broken record on this, but one of the reasons why that is going to be more possible has to do with the metals. Steel fabrication, one of the most carbon intensive things out there. The push for hydrogen, industrial hydrogen, green hydrogen, sourced not from natural gas, but made from renewables or capturing landfill gas and things like that, that's being driven by the need to find cleaner ways to make steel. So if you suddenly can source your steel from foundries that are making it with hydrogen as their energy source, and it's green hydrogen, suddenly that becomes very interesting. So that then allows the foundry to supply steel to automakers, and the automakers are now well on their way to being able to say, we've been able to deliver you this vehicle manufactured without any carbon pollution. The metals are the biggest part of that, of the manufacturing process. And then, of course, the recycling of materials that have already been used and doing that in a more sustainable way. So all of these things feed into the other. If you have a larger industry supplying green hydrogen for industrial application, for stationary power, or to swap out natural gas and instead use hydrogen to create your energy, that allows so-called green steel to now flow into the auto industry. So that's very beneficial. At the same time, as that industry is supplying more green hydrogen for industrial applications, that makes it cheaper and better, techniques to make it available for, say, heavy-duty trucking. It just seems so exciting with as many of these technologies come close to maturity and wider adoption, they all sort of flow into the other. There is this sort of intermingling of all of these things, whether it's renewable power, hydrogen power, batteries for for consumer vehicles, cleaner steel for the auto industry. There are a series of positive things that are happening, and they don't necessarily all start in transportation, but transportation will benefit.
Transportation's the glue that connects it all. I'm getting really fascinated now with the way you're describing green hydrogen and the positive benefits to the environment. Then I start thinking, putting my engineer hat on, what type of infrastructure is needed to deploy and support green hydrogen?
Well, the benefit of hydrogen is that, again, you can think of it as a swap out for natural gas at some point. You can pipe it. You can run it through pipelines. You can truck it. You can make it on site. Hydrogen is just an energy carrier. The problem up to this point has been, and the argument against hydrogen, is the energy required to make a kilogram of hydrogen and store it is negative. So you put more in to make it than you'll get back, which is true. That's absolutely true. If, however, you are making your hydrogen from, let's say, sunlight, electric energy, hydroelectric power, wind power, and you're using fresh water and you're converting water, making your hydrogen from water, you've used a natural input in the form of water, you've used renewable electricity. If your source of that electricity was the sun or the wind, they're free. So your efficiency argument, you're correct. Would it be more efficient to just charge up a battery? It would, of course. But now you don't have the same utility with that battery that you would have with the hydrogen because, again, the hydrogen can be manufactured for direct use. It can store energy and then turn back into electricity. It can be trucked. It can be piped. It can be moved around. And if your inputs were free, especially in the form of your energy, if it's free sunlight, do you care about the efficiency argument? We have no shortage of sun. I'm in Los Angeles today. It's gorgeous. We have sun all day long, all that you could possibly need. We got a lot of sun. When your input is free and abundant, I don't know that the efficiency argument, which has been used as a knock against hydrogen, always holds up. It can in some cases. And, hydrogen doesn't work for everything. But as that industry develops, as the ability to make ever greater quantities of hydrogen from green inputs or to capture landfill gas, which is already filtering into the air as that's already happening, if we can capture that and use that as a source for more hydrogen, if we can make more hydrogen from renewable sources, it begins to look way more compelling. And that supply base just grows and grows and grows. And as it does, then that helps convince trucking companies and other companies to switch from, say, something like diesel to a cleaner fuel that can also work within a conventional diesel or ICE powertrain.
With the focus on the sunlight, does this become a growth market in the Southwest, Southern California, and then the Southeast, just based on the availability of sun historically?
Could be, yeah. So you could have large-scale refineries through, the sunshine states, basically. The water argument, as it's been explained to me, is the amount of water you would need to manufacture a fair amount of hydrogen. It's going to be less than the amount of water that would already be needed for a conventional power plant. So it's actually not as water intensive as just a plain old normal gas plant or a coal plant. It's very interesting, and there is so much movement. Much of it it's focused in Europe right now for the most part. There is activity in the United States, and there's a lot of money flowing into this. We haven't seen any of the big energy companies make major moves yet, and that'll be the signal of what's happening. So, have Shell, for example, does have a pretty robust hydrogen program. ExxonMobil hasn't done much in that space. A lot of the big oil companies haven't yet moved there. Once they decide that that's a good play for them, I think that's when everything starts to move real quick.
That's a valid point. I remember years ago, I'm not sure if it's still there, but Shell had a hydrogen refueling station in Santa Monica, California. And that was the first one. And I believe it was Chevron, closer to the 405, had one as well. And those were the only two that I ever saw in the wild were in Santa Monica.
We have a small hydrogen fueling infrastructure here in California. I think currently it's maybe about 40 stations in the state. Most of them are concentrated in around Los Angeles and Orange County. I did see that a new one just opened up in Baldwin Park today. So I guess there's a new one, but it's tiny. And hydrogen for fueling for passenger vehicles is a little more complicated because you do need a bigger network. This is why, again, trucking looks more interesting for hydrogen, because if you're a fleet operator, you can build a centralized fueling depot to handle your fleet. That's easier to do. And that it's simpler if you're using a network of trucks that are returning to the same place or the same couple of places versus in the passenger market where we drive all over the place. And so you need more coverage. So again, that's why for trucking, hydrogen starts to look a lot more interesting, and it just makes more sense.
It will be very interesting once the oil majors go into hydrogen. At some point, they probably will, because BP is now exploring electric vehicle charging. Shell is exploring electric vehicle charging. And on the backside of that, Shell's exploring, through a partnership with Colin Roche and the team at SwiftMile, micromobility charging. That's interesting that big oil's moving into the electrification of micromobility and electrification of vehicles. They've got the balance sheets. When that happens and they move into this in a big way, and let's say Chevron goes, ExxonMobil goes, what happens to the EV charging companies? Do they go away when the big oil majors move in?
I don't know. That's a good question. Or do they just buy them up? Because again, they have pretty deep pockets. So I don't know. That remains to be seen. There are, as you say, there are some sort of modest efforts happening now. Clearly, those will scale up. Yeah, it could be a mix. You could see some companies that go under, but my guess is that they may just, partner or acquire existing companies in some cases. But we'll see a lot of that, as soon as they make the determination that it's a good business, that there's a good long-term business opportunity for them, they will do it. We're sort of reaching, critical mass with many of these technologies where something that was not viable or economically viable without a lot of support suddenly is starting to look like, now this thing can stand on its own. And then can it make a lot of money? And if it can make a lot of money, we better be in there. Perhaps we're getting close to that now. I don't know for certain.
I'm going to root for green hydrogen. Let's go. And especially as you start this conversation in industrial, it just makes perfect sense. It's good for the environment. And Alan, we've talked a lot about carbon-free, reducing carbon. There's no doubt that environmental friendly mobility is the future of mobility. In your opinion, what does a carbon-free mobility future look like?
Well, that's a great question. It's hard to know exactly which path it's going to take because there are many possible paths. But I do think, clearly 5 to 10 years out, the range of options for very green mobility will just continue to get better. I think we've talked about on the manufacturing side, the fact that many of the vehicles themselves will not only be electric, but ideally will have been manufactured in a way that is not producing added carbon pollution. Whether it is a personal vehicle or, a robo-taxi, that's going to be something that's operating most likely with a battery. Charging should be a bit more ubiquitous within that 5 to 10 year time frame, where it just becomes sort of a no-brainer to do it. Obviously, it'd be great if we were doing more of everything, more e-bikes and all sorts of things. But, I think the right things are happening, and the options look quite attractive. I think both electric and autonomous, and ideally technology that's been produced without emitting massive amounts of carbon pollution are all within sight.
If I put my business hat on here for a minute, decarbonization is one of the greatest business opportunities over the next 10 years, if it can be scaled and be scaled in an environmental friendly way. Yeah,
that's almost verbatim what Tom Linebarger at Cummins said. Cummins are the biggest diesel engine maker out there, right? But they're totally prepping for this transition. And it's exactly what he said. This is an enormous business opportunity for us.
And that's why the gentleman's the CEO of Cummins, because it's smart leadership. And Alan, as we look to wrap up this super insightful conversation, what would you like our listeners to take away with them?
I've said it before, and I'll say it again. There is so much to be excited about in terms of what is happening. I know in the EV space, for example, Tesla gets a disproportionate amount of attention, and that's probably because they're the biggest maker of EVs, and Elon's a larger-than-life character. But there is a lot more to be excited about out there. than simply Tesla. When we're seeing whether it's General Motors, Ford, Cummins, Union Pacific, Wabtec, this whole range of companies, some of the more interesting startups with Rivian and Lucid with really compelling new products. There is so much really cool stuff happening, and it's directionally all the right stuff. It's no tailpipe pollution, manufactured in more sustainable ways. And these are also, on the consumer side, just terrific vehicles. I mean, I think 2022, this is going to be such an exciting year because there are so many great new EVs that are coming to market this year. So there's a lot to be excited about, whether you're a consumer and if you care about the environment. I mean, the good news is there are things that are coming that are moving in the right direction, the adoption of ever cleaner types of energy. I'm pretty upbeat about where things are heading directionally when it comes to the transportation industry.
I love the line, all the right stuff. The industrial companies are doing all the right stuff. The mobility transportation companies are doing all the right stuff. They're doing good by the environment. They're decarbonization. They're going to make the planet a cleaner, better place for us to live. Because, Alan, the future is bright, the future is autonomous, and the future is carbon-free. Thank you so much for coming on the Road to Autonomy today.
Thanks, Grayson.
Thank you for listening to the Road to Autonomy podcast. If you've enjoyed listening, please rate, review, and subscribe on your favorite podcast platform. Want to get in touch? Follow us on Twitter at Road to Autonomy or email podcast@brulteco.com. The Road to Autonomy is produced by Brulte & Company. The views and opinions expressed on the Road to Autonomy podcast do not necessarily reflect the views and opinions of Brulte & Company. The content discussed on this podcast is for informational purposes only and should not be taken as legal, tax, investment, or business advice.